Let's start with the unit test that you should normally implement, which is for right input values, do we get right results? Unit tests, as we discussed on Tuesday or on Monday, are simple methods. So once again, clean code principles should be implemented when you write unit tests because they are functions. So they should be simple, one screen. They should have a single responsibility, which means they should test only one condition, and that translates to they should have only one cause for failure, which means if the unit test fails, you have only one reason for that. So all the clean code principles should be also used here, okay? Because unit tests are just functions with a different objective, but they're still functions. If you are in JUnit 3, starting with the test keyword is mandatory. Like I said on Tuesday, I will still write, even in JUnit 4, with this pattern, okay? Just to provide bridge between JUnit 3 and JUnit 4, or because this is the way I used to write unit tests in JUnit 3, and somehow it looks normal for me. So we start with test, and after that we use this pattern. We set the name of the function that we want to test. So in our case is get grades average, get grades average, and the third value here, or the third name, should be the condition. Okay, what do we test here? So when this test will fail, we will just by seeing it, we know that it's failed because of get grades average, and now we should have another info like right values. Okay, which means right values means right results. Sorry, I have the keyboard on Romania. Let's switch that. So which are the steps that we need to take when you write a unit test? There is this, let's say, cascade of steps. And for the first unit test, I will write the comments just to help you see them. And from one point, I will avoid doing that, and we will just follow the steps. So this should be natural. So the first step that you should do is to define input data. Okay, so what is the data that you want to use in order to test that method? Now we have a compiler here because I forgot to set the brackets for the function header. Okay, so just correct that. So what is the data that we need in order to test get grades? This is a student class method. So in order to test it, we need a student. And we know it's processing the student's grades. So once again, we need to create a student. We need to provide a student that has some known grades for which we expect an average or a mean. So let's create this set of data. So I will start, because if you remember, the student class has a constructor which is receiving an array list, and that will be the student grades. Let's define it. Yeah. So these are my, I don't know, input grades. Okay. And equals new array list. Okay, we have an array of input grades. Let's add some grades into this. Input grades, add, let's say 9. Input grades, add 10. And input grades, add 9. Okay, so we have these 3 grades. Now, normally here you should choose right values. So I consider that these are right values because they are valid, and we have 3 grades, okay, and their values are okay, 9, 10, 9. So this is the input data. Let's create the student. Student equals new student. Based on the order of the arguments, and remember we generated a constructor, we have name, age, and grades. John 20, and the input grades. Okay, we have the student. We need to add the student. We import the student class. That's the reason for the error. So now we have a student. This is our input data in order to test get grades average. Okay, what's the second step? The second step is to define the expected result. So we choose the input data, which means we know what the result will be, the right result. Float, expected average, equals. So in our case, if I'm not mistaken, the average should be 9.33. And here you will have a compiler error because I remind you that Java is a strong type language and is not accepting default conversions. By default, any floating point value is double, and here you have a compiler error saying I can't convert a double to a float because you may have you may lose precision. So you can either go for add cast to float, or you can use F here. Okay, this is the expected average. So this is the second step. Define input data, define expected result. Okay. The third step is test the function and get the result. Float computed average equals with student dot get grades average. Okay, we got the result. How do we know the function works? And this is actually the unit test objective. We need to compare them, and here we have two ways to do that. Either by using our own way of doing it, like writing an if computed average equals expected average, or if they are different, I don't know, fail the test or whatever. And this is a, let's say, a manual way of doing stuff. But because we are working in JUnit, and because we need a single instruction that will do the check, and in the same time will mark the unit test as fail or with success, all unit test frameworks like JUnit, and generally this is the idea for library, they provide you a set of methods that will do that, and they all start with assert. Okay, so in order to, this is the final step, compare results and finish the test with fail or success. So we have this set of assert functions. You don't need to memorize them. You just need to memorize only this word. And in English, assert means evaluate, check, test, whatever. So it's easy to remember the name because it's something that makes sense. And also it's something you have seen in other languages. Remember in C++ when you had very strange runtime exceptions, especially when you mess up in heap with creating the allocating space, you had those strange runtime exceptions with assertion, what something. So once again, this is a keyword that has a lot of meanings in computer science and in a lot of languages. So assert is a word that you will memorize. Now, how do you deduce the function name, the real assert function name? By using IntelliSense. Okay, just type assert, and after that control space, and now you will have a wide range. It's not an infinite list of assert methods. It's limited. Now, at the beginning, the set may look large, but it's not. And all the functions, they have meaningful names. Like, you see, assert array equals, which means it will always compare if two arrays have the same values, not the same reference, which is what you should always check. And what the reason for seeing a lot of assert array equals methods is that they provided you a method for each data type. You see, you have for byte, char, int, long, object, short, double, float, and so on, string, and so on. So that's why they may seem there are a lot of assert functions, but if you play with only one data type, the actual number of assert functions is very limited, 3 or 4 for each data type. Okay, now let's see, assert equals, and I'm seeing here that it's asking for 2 values. So maybe for comparing the average values, this is the function that we need. Assert false, assert not equals, assert null, assert same, assert that, assert true, and so on. We see them here. So let's go for an assert equals, because this is like writing your own if value equals another value. And what you will see here for assert equals, and this is valid for all the other assert type methods, once again, you will see 2 versions. For example, let's search for the one that we need now. We need an assert equals for float values, and I see it here. Assert equals float, expected float, actual, and I see a delta. I will explain what's with that. And right after that, you have the same combination, but with an extra input argument at the beginning, which is a string and a message. And I will always recommend you to go for this version with the string at the beginning. Why? This is a string. This is a message that you will write now. And always remember that that message is for you. So in unit testing, the developers are writing their own unit tests. And when the test is failing, you will see in the report here, in the left side window, you will see which test has failed and the message. And the message that you will write now in the assert method is the message that you will see in the report. So try to give you hints that will help you find fast the bug or the problem in the function that you tested. Okay, so don't write here messages for end users. Write messages for developers. So be technical. Give details that maybe only a programmer will understand. Okay, something like check the reference in whatever class. And for a developer, that is a very valuable information if you have a bug regarding that reference. Okay, so I will go for this version of the assert equals, and also for any assert method that we will have. Okay, now IntelliSense, it's playing here, and it's always here. It's moving the cursor at the end of the function, and sometimes it's annoying. So just hit escape to close it. If the test will fail, it means we don't know how to compute the average. Okay, so the average is not okay for right values. Okay, or I don't know, maybe the algorithm is not okay, or check the algorithm. Okay, now you see the next argument is the expected value. So we have this value, it's expected average. The actual value is actually, it's the computed one, computed average. So you have the 2 values from step 2 and 3. And the last argument is a delta, which means for floating point variables like float and double, because they are stored as a scientific expression, you should remember this from first year. The idea is that they are not stored as numbers. For example, 9.33 is not stored as you see it. It's an expression, it's a formula, which actually is approximating that. And sometimes it's not able to approximate that because you need many digits, and a float can't store, I don't know, more than 30 digits or less than that. So floating points are always approximated. Only in, I don't know, in particular cases, you actually store that value. And I will show that to you. Now, I think 9.33 is one exception, but if we change that to a different value, you will see it in the debugger that is not what you write. It's an approximation. So floating point values are dangerous for modern computers because they are not stored like you may think. They are actually approximated based on their scientific format or scientific representation. Okay, so in many cases, in order to compare two float values, we need a delta or a margin of error. Something like we accept a small deviation from the expected value with this deviation, like plus, minus, whatever. So in this case, let's go for a 0 deviation. Let's see what will be the result, and we will fix this, because I want to show you the issue with floating point values. Okay, so 0 here means the computed average should be identical with expected average. So the margin of error is plus minus 0, which means the same value. Okay, so we have the unit test, which is testing get grades average with right values. This is the unit test. Let's run it. Right click, run as, or you can use the run here in the toolbar, in the Eclipse toolbar. It's the same. And now we check the left side window, and you can be, let's say, surprised that the number of unit tests here is the same. It's 1 out of 1. So this is a common error which you can do easily, and it's a pity because the unit test could be okay, but is not taken into consideration because it's not a unit test. It's just a function in a test case. And we know that we can write any functions we want in a test case, but we need to do something extra to mark them as unit tests. So if you write a unit test, run the entire test case, and you don't see any difference here in the left side, you still see the previous number of unit tests, always check if you mark this function as a unit test, because now is not a unit test. It's just a function which is not executed. So in JUnit 3, check if your function starts with test. Okay, we are not in JUnit 3, so you see for JUnit 4 that doesn't make any importance. It doesn't have any importance. And in JUnit 4 and also in JUnit 5 or Jupyter, you need to do this. So always check in this kind of situations, always check if you mark the function as a unit test. So we corrected that. Let's run it again. Run as JUnit test. Okay, so now we have 2 unit tests. How do I know? I see the list here on the left side. So there are 2 of them. One is called test get grades average right values. Okay, and the other one is the initial test with fail. We have 0 errors, which means it's okay. We don't have any Java problems in any of the unit tests, and we have 2 failures. So for the moment, that's okay, because having a failed unit test is the main idea of TDD, test-driven development. Write unit tests that fail, fix the function, and the unit test should pass, which means should go on green, should be a green test. And you will understand why everybody is saying by fixing the function, the unit test becomes green, because the icon of a success unit test is green. So that's why they're using this expression. Okay, now let's check why the unit test has failed. Okay, just a moment to zoom on it. I need to share the entire screen to do that. So I will zoom on it on Eclipse, and I'm selecting test grades average right values. So I have selected the function here, the unit test, and now the failure trace is focused on this unit test. That's why you need to select it. Okay, and now let's hover the mouse over the message, and it's saying the average is not okay for right values. So this is our own message. Okay, and now you see all assert methods in order to help you get more details about the reason that the unit test has failed. So in the end, you should fix the tested method easily, it's always giving you this detail. And that's okay because we don't need to write that. After your message, it's always adding this expected value. So you see, it's our expected value, 9.33, and it's saying, but was 9.33333. The reason for this unit test to fail is the fact that here we got in the computed average 9.33333. And we want to compare that with 9.33, and actually the two values are not the same. So one is bigger than the other, even if the difference is very small, is like 0.0033333 and so on. It's a difference. Okay, so that's why for floating point values, you need this delta, because it's very easy to get into this kind of scenarios when you need to compare two floating points and you have a difference in terms of the third, the fourth, the fifth decimal, and so on. So the test has failed. At this moment, we need to ask ourselves if the if function has been implemented correctly. We need to go back to the specifications and read that again in order to be sure that we implement it correctly. So in our case, let's suppose that the function will always return the average like this. There is no requirement that we should round it to only 2 decimals. Okay, this is how they ask us to implement it, by just giving a float value back, and from our perspective it's okay. So let's assume this approach. The get grades average is computing the value as a floating point type and is returning it without truncating or rounding the result to 2 decimals or 3 decimals. You know that in real life we are using your average only 2 decimals. Okay, but let's assume this case for our example. So how do I compare them now? Because I understand the difference. In that case, let's assume that we accept a delta of 0.005. So it's like the first 2 digits should be kind of the same, or I can accept a difference of plus 0.005 or minus 0.005 regarding my expected average. Okay, so for floating points like types float and double, always consider this delta. I don't know, there are sometimes situations when you need to have the same value, exactly the same. So in that case, pass a 0 delta. But in our example here, for the given input data, we accept this delta, this degree of error. Let's run the test again. Let's see that, let's check if now the unit test is passing. So right click, run as JUnit test. And now the unit test is green. You see, it has a green icon. That's why it's called a green unit test, which means it passed. Okay, so it's a green unit test. If you select it, there is no message here because we don't need to do anything about it. It's a green unit test. We have 2 unit tests out of 2 executed, and 0 errors and 1 failure. And this info is also visible here. Okay, so this is how we will write unit tests. Okay, passing through this 4-step phase, and generally based on single responsibility, which for unit test means a unit test should check only one condition, and having these assert methods, the conclusion will be that the unit test should have at least or optimal one assert function, because that function will terminate the unit test and it will mark it with either success, green icon, or fail, depending on how the values are. Okay, so this is the basic unit test. If you have questions based on this example, if you find something which is not, let's say, clear, Let's see what else can we test. What I wanted to show you earlier, the floating points. You don't need to do this. So I will just write here 9.2. Okay, so I just changed the expected average to 9.2. Now the test will fail. Everybody can be sure about it. But what I want to show you is this. So the test has failed. And if you check the message, you see expected is not 9.2. Is 9.1999980 and other digits. Why? Because floating point values, they are not stored, they are approximated. So you have a formula, which is the scientific representation of a floating point, and it's actually a formula. It's like the comparison between a bitmap, you had the multimedia class, of course, and SVG, which is a vectorial type. Remember, in a vectorial image, all the drawings are actually represented by functions and set of values. It's like the viewer is drawing the image based on mathematics. And in a bitmap, you have actually each pixel with its own RGB code. Okay, so this is the difference between a floating point and an integer, for example. Okay, and this is one example. So 9.2 is not actually 9.2 in memory, it's an approximation. Okay, so I will switch it back to the correct value. The second unit test. Let's test another condition. So we tested for right values. So at this moment, we know that the function is implemented correctly, at least from this perspective. We passed 3 values and we got a result. Let's do another unit test. So at test, public, void, test, once again, get, what's the name of the function? Get grades average, okay, and let's test another condition. For example, I want to test this particular condition. What will happen? I know what should happen. When you unit test something, you know what the function should do. Okay, so this is not something which you need to, I don't know, pick or choose. It's something you already have decided. So let's see if the function is behaving properly if the student has no grades. So you have test get grades average, no grades. Now, no grades, it means you have the array list, but there are no grades in it. Okay, it's an empty array list. So let's establish the initial data by going through all the unit tests. Before doing that, please run this test case. So just implement the unit test with an empty body. Test get grades average, no grades. Okay, we have it here. We have the test at test marker, the annotation. So let's run this test case. Right click, run as. I want to show you another thing regarding unit tests. And if you check once again the left side screen, we see we have now 3 unit tests. Okay, one has failed, which is still test, and that will fail forever. Okay, and we have 2 unit tests, and they are both green. So what's the conclusion of this example? Any unit test that you write, which is doing nothing in terms of comparison, which can be translated to is doing no assertion, it will always be a green unit test. And these are the most dangerous unit tests that may exist, because if you have 1,000 unit tests and you see that they are all passing, you may think that your functions are implemented correctly. Okay, and you may have this kind of unit tests, empty body, or the developer has forgotten to implement an assert. So they will give you the assurance that everything is okay, that you are actually in a blind spot. Okay, You don't know for sure. And later you will find bugs. And once again, this unit test will, I don't know, guide you on a wrong path because you may think the function is correct. All unit tests have passed. They are green. So you will lose a lot of time to realize later that actually the unit tests were wrong. Okay, so that's why in TDD, everybody's saying write unit tests that fail. And you see, this is the reason that when you generated a test case, the designer, the Eclipse in this case plugin, or the IntelliJ plugin will always write this fail, not yet implemented, or to do, don't forget to implement it, or whatever. Because by default, without anything or a fail or an assert method, all your unit tests will pass. Okay, so this is quite a dangerous thing. Maybe they will change this in the future to mark all the unit tests without assert or a fail, or by a compiler error or whatever, because this is a mistake that you can easily do. Okay, now let's implement it. So what's the initial data? Once again, we need a student. Okay, so you'll be tempted to do this, to copy paste. And let's say I will copy paste this part. Control C, Control V. Okay, so based on clean code, when we copy paste something, this is what's the principle that we break from clean code?
Dry.
Dry, exactly. So the opposite of dry, it's actually wet. Okay, and it's actually translated in we like to type, or we type everything twice. This is the WET. We type everything twice. So this is the definition of wet, which is the opposite of dry. Okay, so how do we avoid dry? We write a function, and that function will be reused. Okay, once again, this is actually the entire scope of a function to be implemented and to be reused many times. Okay, so at this point, we may think here to define a function called init student, or create initial student, or something that for us has this meaning. Instead of copy pasting that source code each time for each unit test, and it's obviously we will need that many times, because remember, we are unit testing functions from the student class. So in order to call any of those functions, we need a student. So this is like something we will do for almost all unit tests. So we will name that function in different ways. Init, I don't know, initialization, whatever. Now, the problem is that maybe later another colleague will take your part and will develop the same module as you, and it will add new unit tests. So at that point, he will create maybe its own init student method, because maybe it's not seeing yours, or it has a different philosophy. So the conclusion is that in most cases, you need the function to init the data that you will reuse. In this case, is the student. You need the student for all unit tests. So can we define that method in a standard way, so any programmer, you or another person later, will identify it as the function that should be used to init the student, or the resources that all your unit tests are needing? Yes. And the standard name is setup. And they actually, all test cases in JUnit are already implementing it. Remember when you created the test case, you had those 4 options to check: setup, tear down, setup before class, tear down after class. And we actually generated, by checking those 4 options, we generated these standard methods. And this is their scope. So instead of creating your own init, create whatever methods, use this, because anyone who is working with JUnit or any other library, all the other libraries have the same philosophy. Like I said, if you understand unit testing here, you understand unit testing in any other languages, because it's the same story. It's like learning object-oriented programming. they all have the same methods. Maybe they are not called with the same names, but they have them. So in order to understand how these functions behave, let's see that instead of, I don't know, taking as granted what I'm saying. Sometimes it's better to test yourself and learn by what you will see. So let's try to implement here simple messages. So remember, you have a shortcut. In IntelliJ is sout, control space, and in Eclipse is CISO. Okay, so control space, system out print line. Let's write the function name, setup global. Okay, in tear down after class, let's do a tear down global. Okay, in setup, just setup, and in tear down, tear down. Now the names, I think they are meaningful to you. So tear down is like a garbage collector or a cleaning routine. So tear down is like breaking up or cleaning up after you. Setup, everybody knows what's a setup. And before and after class, I think they already suggest what will happen. So we have implemented simple messages in all these four methods, okay, with the system out print line. So if we rerun the unit test, the test case, run as JUnit test. Okay, now in the left side part of your screen, you will not see anything new. There are still 3 unit tests, 2 have passed, 1 is failed. Okay, now what you need to see is the console, because remember, every time you are using system out print line, you are playing with the console. So we need to check the console. What do we see here? We see the messages, and based on the sequence of messages, now you can learn when those methods are called. Remember, we just implemented some messages. We didn't change anything in the test case, so we didn't explicitly call those 4 methods. And when we run the test case, we see they have been executed. So what's the first conclusion? Those 4 methods are executed by default when you execute or run the test case. Okay, so if you have them, they will be executed. If you want to stop that, you need to remove them. Okay, so they are executed by default. This is great. We don't need to worry about this. Now, based on the sequence, on the messages sequence, what's their order? We see a setup global right here at the beginning of everything. And after that, I see a tear down global, which is the last line in the output. So what it means that setup before class is executed once, only once, before all the unit tests in the test case, and tear down global is executed only once after all the unit tests. It's like the last thing that will happen in your test case. And in the middle, in between them, you have this sequence of, and it's a pattern, a sequence of 3 pairs: setup, tear down, setup, tear down, setup, tear down. So what's the conclusion? Setup is called each time before each unit test, and tear down is called after each unit test. And if you write a message here, whatever in any of your unit tests, you'll see that message here in between setup or tear down. Okay, so these are actually the standard methods that you should use in order to create your resources or cleaning up after them, after each unit test. Why do you need to clean up? Because when you run unit tests, they should be independent, which means if you have a sequence of 10 unit tests, the 3rd unit test result, which means success or fail, should not be influenced by what has already happened in the previous two unit tests. So each unit test should have its own data and they should not be linked. Okay, it's like each unit test will think that it's the only test that is executed or has been executed ever. Okay, that's why you need setup and tear down. And the global counterparts, which is the before and after class, are actually some global setups that you want to do only once. I will give you an example. We may have a class which is testing a connection with a database where we store students. So we have our own controller, which is retrieving students, updating students, storing students in the database. So we want to test it. We have two approaches. We open the connection each time we do a unit test here in setup. So what will happen? You have 1,000 unit tests. When you run that test case 1,000 times, you will create a connection. And obviously, you will close it here in tear down. So those unit tests will require a long time to be executed because opening a connection and closing it is quite a costly operation. Okay, it's involving a lot of steps, so it's costly. It will take time, and it's an overhead. Why do you need to open the connection 1,000 times? Can't you open it only once and reuse it? So you see, this is a case where the connection should be opened once here before all the unit tests, because actually you need only one connection. You don't need 1,000 connections. And the connection will be created in setup before class, and in setup, in the simple setup method, I don't know, you create your objects or the data that you want to store, update, whatever. So you focus only on that transaction. What do you want to do? Okay, so don't create your own init something methods. Use setup and tear down. Okay, so this is their purpose. This is why you sometimes need them. Now, in JUnit 3, you don't have these two classes. That's why JUnit 4 is fixing that for JUnit 3. In JUnit 3, you need to find a workaround, which is an overhead. You need to create a test case and to include the other test case into that. Now, setup and tear down in JUnit 3, they need to have these names. Okay, so once again, JUnit 3, you don't have the before and after annotation. And in JUnit 3, you need to have these methods with exactly this name. You see, when they generate the functions in JUnit 3, they preserve the names. But like I said, they have zero meaning for JUnit 4, but I think they preserve the names in order to help the transition from JUnit 3. So if you have experience in JUnit 3, you will recognize the names. But they are not important in JUnit 4. Okay, so let's avoid the dry. So what I want to do is to remove this part here. So I'm in test get grades average, not no grades, where we copy pasted the part from the previous unit test. Okay, Control X or right click cut. We don't want to do the copy paste here. So let's move that part into setup here, Control V. So anytime we will need a student, the setup method will create the student for us. Because we need an array list, we keep this part. Okay, so let's suppose we establish that by default, any student will have 3 grades with those values, 9, 10, 9. Now you can change this behavior here. Okay, you can say all our students will have no grades, or they will have a null reference, whatever. Now depends on specifications and what is your guideline regarding creating a default student, which should be the default values. Okay, so I don't know, what do you want to do? Create a null reference for grades, or create an empty array list, or keep this array list with 3 grades? How do you want to continue? Which version do you want to have? empty array list. Okay, so yeah, let's go for an empty array list, which means I will remove this part here. Okay, so we have defined input data, input grades equals array list, it's an empty array list. And now we create a student. We can say empty name, not null, it's an empty name, age 0, for example, or by default, it could be, I don't know, 18, whatever, and input grades. Okay, so this is our student. Now, how do we use this student in the unit test? If we have it, it means we can use it, right? So here I will write float, computed grade, average, sorry, equals with student dot. Yeah, but you see, when you write student dot, the IntelliSense is saying nothing, which is kind of strange because here it should suggest get average. And if you really try to force that and really write, you see, let's copy this part here from the previous test, which is exactly what we want to write here also. Okay, you will have a compiler error saying student cannot be resolved because it doesn't exist. So why we don't see the student? Because this is normal to happen. Why? Because the student reference that we have defined here in setup, it's a local variable. So the idea was to create a student here in order to reuse it in our unit tests. We did that, but the reference is a local variable, so it's not visible outside setup. How can we make it visible? We remember that we are in a class. Okay, so just ignore the fact we are in a test case. We are in Java and we are in a class. So in order to define resources that should be visible inside unit tests in this class, use the class attributes. So you have a reference for a student, which you need in all unit tests, define it here, student. And if you need anything else, later we will need other values. Always define them here as class attributes because they will be visible in all your methods. Okay, this is the advantage. So the collection of resources that you need in order to run your unit test, which means the collection of resources that you need to share with your unit tests in a test case, is called a test fixture. Okay, a translation will be like a collection of tools or resources needed by this test case. Okay, but this is the name, test fixture. And once again, the same keyword fixture is used in all unit test frameworks. Okay, they preserve the name. Okay, so it's a cross-language term. Okay, now we have defined the resource here, but at this point that will not fix the problem because now student is visible here, and if you run this, save the test case, you will see that the error has disappeared because now we have a student reference here. You see it's written with blue, and the same color is also visible here, which means it's the same reference. And you should not have any compiler error saying student is not reference or defined. Now, if you run the unit test or the entire test case, right click, run as, let's close the loop, run as JUnit test. Now we see something new here. We see an error. Okay, which means we have a mistake in one of our unit tests, which means the unit test is not correct. So that's the difference between fail and error. Error means the unit test is not correct. It's you have a mistake. You need to fix that before running the unit test. So what's the error? And this is generally a Java error, like I said. It's very visible which unit test is the one with the error. Always check the icons here. Okay. And if I select it and check the failure trace, I see Java lang null pointer exception. And if you double click on the trace, it will show you which is the line that generated the null pointer exception. And I think it should be clear that the null pointer is the student. Why? Because when you define a reference as a class type attribute in Java, this is by default null. Okay, so when you try to use it here, it's like calling get grades average for a null student reference, and we know that this is not possible. So this is the reason that the unit test is not implemented correctly, because it has the error. Okay, so why do we have it? Let's roll back through the previous steps. We define the reference here in order to be able to see the student in all our unit tests. We know the setup method is executed before all our unit tests, and for this reason we created the student here by writing this. But what's this? This is shadowing. Remember the shadowing problem. If you define a local variable with the same name of as a class attribute, you are shadowing the class attribute, which means this variable is the local variable, is not the class attribute. And you can check its color because it's not blue. Okay, it's not written with blue, which means it's a different variable. So watch out for this kind of mistakes. This is another way of writing bad unit tests. So don't do shadowing. Don't redefine your variables. Okay, so just init your class attributes. And you may conclude this new rule. In setup, try not to define local variables that you may need in unit tests, because they will be local, so you can't use them. So generally, setup should initialize class attributes, because those are your variables which are visible in all your unit tests. Okay, so let's see if this has fixed the problem. So if I move here, now I see student, once again, it's with blue. Okay, now if I rerun the unit test, right click run as JUnit test. Okay, now it's passing. We know why, because we don't do any assertion here, but the error is gone, which means we don't have a null pointer reference. Okay, so we know what's a test fixture. It's a collection of resources that unit tests will need in that test case. We know that generally it's a collection of class attributes. We have seen when setup and teardown are called before class and after class, and the standard ones. And we have seen what's their scope and how to use them by initializing class attributes. So this is the way we will write unit tests from this moment on. We will avoid dry, we will not do copy paste, we will reuse what setup is creating for us. Now, because you don't know how setup is initializing your data, you just know it's creating a student, and that should be enough for us. Let's define our own specific input data. Okay, so we are in test grade, get grades average, no grades, right? Which means we should test the get grades average with a student that has no grades. We know we have a student, but we don't know if it has no grades. So because anyone can change setup in the future, so we want to make the unit test independent of the future changes of setup, and the setup should provide you a student. That's it. Don't bet on its values, okay? Because those values can be changed in the future by you or by another programmer, okay? So always use the student, but initialize it with your specific input data, okay? So let's say no grades. equals new array list. Okay, so in this way, I'm sure our student has no grades. Student set grades. Remember, we have a set method, no grades. Okay, so we are reusing the student created by setup, and here I want to be sure that the data is exactly what we need for this unit test. Okay, now define the expected result. So what should be the expected result? If you have 0 grades and you are computing an average of an array list with 0 values, what should be the average as a float? So what value I'm writing here? 1, 2, 3, 0. What? I need to write a value because you see it's a float variable. So I need to set it up to with a value. What's the value should be? Anyone? Okay, 0. 0.00, but 0 is always 0. Okay, so expected average is 0. This is step 3. Compute the average. So let's assert them. Assert equals. Once again, I'm using the string version, the one with the string at the beginning. So here, let's say average for 0 grades. Okay, expected is expected average. Control space, and actual is computed. And because we are comparing floating point variables, we need a delta. So we need the same precision, which means 0. 0 is 0. Okay, we can't accept any deviation. So this is step 4. Let's run this. Run. Let's check the test report. We don't want to see the console anymore. Okay, because I know the result. Okay, and let's check the report. So 3 tests out of 3, 0 errors, 2 failures. I see that the no grades test has failed. Click on it. Let's see the message. Average for 0 grades, expected 0, but was none. So none is a very special value in Java, which is actually is not a number. This is the acronym stands for, not a number, and is not an exception either, but it's still not a number. So if you try to use it and, I don't know, add to none something, you'll get an arithmetic exception. So the first time you try to use it and to process it as a value, you'll get an exception. But you see, there are some instructions that are generating none, and that's not an exception. It's just giving you that value. But like I said, it's not really a value. So the test has failed. Why? Because now we realize that we didn't consider this case when we implemented get average. So let's move back to the student class. And let's check why it's returning none. And I think it's obvious. Why? Because when you have no grades, this for loop is not executed. And the function terminates with return sum, which is 0, divided by this grades.size, okay, which is 0. So you see, the none value has been generated by this division to 0, which in Java is not an exception. In C and C++, it's an exception, but not here. So here is generating a none. So obviously, we have a bug in the function. Now, depending on the specifications, we need to fix it. So let's assume that in this case, the function should return 0, not none. Because remember, this is what we expected. Not an exception, we expected 0. Okay. So how do we fix it? If this grades size equals 0, return 0. So now we fix the function. Remember TDD, write unit tests that fail, fix the function, rerun the unit tests, and now the unit test should be green. This is the red, fix, green, refactor cycle in TDD. Okay, so let's go back to the test case. So this is what I added in the get grades average in order to fix the function, the if statement. Let's go back to test student, right click, run as JUnit test. And now the test, the unit test, is passing. Okay, so you have test get grades average, no grades, test get grades average, right value, everything's okay. Now, once again, you see the test here, which is still failing. Now, in order to fix this one, maybe we will need that later. I don't know. You can do this. You can comment it, but based on clean code, this is not right because we generate zombie code. Okay, so don't comment it. You can remove the at test here. So in that case, it will not be executed as a unit test. And once again, this is not right because if you will check this function later, or some of your colleagues will check it, will be like, why do we have this function here? What's with test? Okay, so once again, it can be, I don't know, misleading. It can create confusion. So if you want to keep it as a test and you just want to ignore it for the moment, you have this annotation, ignore. So let's see. Yeah, and you see, in order to use it, you need to import this library, org JUnit. I don't know why we didn't import. Yeah, I think we imported JUnit test case test and not the entire library. So just hover the mouse over the error and import JUnit. So what ignore is saying to the JUnit framework, saying, hey, this is a unit test, okay, but just don't execute it. So if you run again the run as JUnit test, you see it's still present here. That's the beauty of ignore, because if you remove test, you will not see it here. So it's like it's not a unit test anymore. It's a normal function. So that's why if you want to ignore or I don't know avoid running some unit tests, mark them with ignore, because you will still have that unit test. We have 3 out of 3, and it has this cancel, I don't know, disable icon, but it's still present here. So you will not forget them. If you ignore a lot of unit tests and run the test case, the report will help you, will remind you later you have some ignored unit tests. And this is valuable because otherwise you may forget them and you or other colleagues may rewrite them in the future without actually knowing they are already implemented. Okay, but you just remove the at test. Okay, and the last unit test for today will be this unit test. At test public void test get average grades, get grades average, sorry, grades average. Now let's see what will happen if the grades array list or the grades reference is null reference. Have we considered this case? So what's the setup here? We need a student with a null reference for the grades. We have the student, it's already created. Set grades null. Okay, this is the input data. Now, when you have a null reference for your grades array list, what's the expected result? What should happen? If I'm asking you to compute the grades of a student and the student has a null reference, how that sounds? Do you find it as a very strange situation to ask you to do that? Because it's not normal, right? It's like, I don't know, in real life, you are a student, you have a grade book, but it has no grades. It's like you don't have a grade book, right? Having null reference. So let's consider that in this case, this is not normal. To ask me to compute an average for a student that has no grades, this is not normal. So in this case, we should expect for what? For an exception. Because it's not normal. It's like I enrolled you as a student, but I forgot to create a grade book. Now, we accept the situation when you have no grades, but let's consider that having a student with a null reference is not normal. That should never happen. So the only way to warn me or others about this fact is what? To throw an exception. Because that programmer has created a student with a null reference, and it now is trying to compute its grades average. Okay, so how do you do this in order to check for an exception? Normally, you will do this, right? Try student get grades. We can write float computed grade equals, but let's remember we expect for an exception. Catch. Now I will go for an exception, generic exception, which is not quite okay, error. But next week we will switch to custom exceptions because we know how to define custom exceptions. So we will, in this case, we will create a custom exception called no grades or null reference grades exception, something which will be very obvious. Okay, so how do we mark the test that has failed or passed? Now let's think for a moment. If the function is not throwing an exception, it means that the next line will be executed, right? Remember, this is how try catch behaves. If you do something which is not throwing an exception, the try block will continue to be executed, right? Because you got no exception. So if we expect here an exception and we call the get grades method and you don't get an exception, the next instruction should be fail. We got no exception because we expected one. So it's very strange. We expected an exception. We got none. This is not right. The unit test should fail. Now, if you get an exception, how do we mark the test that has passed? Assert true, true, which will always terminate the unit test and mark it with the green icon, because assert true, true is always true. So you see, this is like the opposite of fail. If you want to terminate a unit test and mark it with success, this is let's say a shortcut that programmers are using, assert true, true, because it's obvious. So let's run the unit test. Right click, run as JUnit test. We have 4 unit tests, and the test get grades average null reference, it's not passing, it's failed. You see, we got no exception. Okay, so we got no exception. That's strange. We have 0 exceptions. Yeah, sorry, it's not get grades. Yeah, that's why I didn't see the exception. It's get grades average. Yeah, let's rerun this. So right click, run as JUnit test. Now we are back on track. You see, the test is passing. Why? Because by default, you get a null reference exception. So at this point, you may say, yeah, it's great. The method is implemented correctly. It's throwing an exception, yeah. But in the specification, it is stated clearly that the function should throw a null grades exception. So let's create the null grades exception here in Seminar 5. New class null grades exception. Enter. How do you create your own exception? By extending exception. Okay. So now I have my own type. So let's change the unit test. Instead of catching an exception, a generic exception, let's catch a null pointer exception. Okay. And let's run the unit test again. Run as JUnit test. Now we should see a different story. Yes, but I don't see it.
It's
So,
the other exception. It's null grade exception.
Thank you for that. I was catching exactly what the function is throwing. The compiler is forcing us to mark the function as throwing a null grades exception. So you see how it's forcing us to do good design, because this should be stated here based on specification. So throws null grades exception. Okay, remember, once again, this is a bad design. We implemented the function without actually reading the specifications, and this should be stated that this function may throw a null grades exception, and also should give you details when that exception should be thrown. Now, if I go back to test student, the error has disappeared. Let's run it again. Run as JUnit test. No, I have another error. Yeah, now this breaks all my all my unit tests. Let's use the add throws here and also here, because I don't expect for those exceptions. Okay, so I fixed the unit test by adding throws. Now let's run this again. Run as JUnit test. And now the unit test is failing. And if I choose to see the details, it's saying Java long null pointer exception. Okay, so now the unit test is failing because the function is actually throwing a null pointer exception. I'm expecting for a null grades exception, which is not happening. And now the test fails because we have an exception which is not managed. So let's say for any other exception, once again fail with a different message. And in this case, the message is we got a different exception. So we got an exception, but it's not the right one. Okay, right click, run as JUnit test. Now the test is failing. We got a different exception. So at this moment, we are convinced, let's say, that once again the function is not implemented correctly, because no one took into account this case where the grades array list reference is null. So in order to fix the function, we need to go back to student, and here we need another if. If this grades equals null, throw new null grades exception. And now we fixed the function. Now, if the function was defined correctly and we had these throws, this is a very important hint, because you actually, if you see this header, you realize that at some point you need to throw that. Now, let's suppose we forgot this. We have implemented this unit test, which is specifically testing for this case to see if we test it for null. Okay, so we set the grades for null. We try to call get grades average. If the function is returning no exception, try will be executed, and the next line will be fail. We got no exception. Now, if we catch a null grades exception, it's okay, because this is what we expected the function to do. Okay, or if we get any other exception, we want to cover the case where the unit test will have an error, so we don't want an error. So we cover this case when the function throws another exception, not a null grades exception type. So here I have another catch, and here I have a fail, okay, with a different message. So now if I run this, now the test is again green. But it's green because actually the unit test is written properly and the function has been repaired. Okay, so that's why it's green again. What I want to show you is that, you see, even writing unit test is tricky because you can fool yourself. We had several cases before reaching this phase when the unit test appeared okay, or it has given us failed messages, but they were not the right ones. Okay, so when you test for an exception, always do this approach. Now, because this is the standard way to test for an exception, this is the JUnit 3 version. In JUnit 4, they replaced all this part and they are able to generate it. So they said, hey, this is the standard way to test for an exception, right? Why do we need to write this? It's like doing try again and again for any time you expect for an exception. So, and this is my last thing for today. In JUnit 4, in order to do this, you need to do only this. So test grades average null reference, let's say JUnit 4. This is the JUnit 4 way, and this is the way we will do it from this moment on. Student get grades average, and here you write here as an attribute for the test annotation expected equals, and the type of the exception that you expect, null grades exception.class, and that's it. And had type null grades exception, okay, add throws. Okay. So they improved this kind of test in JUnit 4 by allowing you to write this expected here for the test annotation. It's like an attribute for the decorator. Okay, and the test will fail if the function does not explicitly return or throw that type, or it will pass if that will happen. So if you run as JUnit test, you should see them that they are now passing, this one and the previous one. If you choose JUnit 3, this is the way to do it in JUnit 3. This is like manually doing what now JUnit 4 is doing for you. And in JUnit 5, it's similar in Jupyter. Okay, so this is the way we will test for exceptions. You will see how we will do tests for expected values with asserts. And for exceptions, this is the way we will do it. I will show you next week how to do performance tests, how to measure. Maybe you have a requirement that grades average should compute the grades. Suppose you have 1 billion grades in less than 1 second. So we need to find the fastest algorithm. So you have a performance criteria for your methods. So in that case, you need performance tests. So I will show you how to do performance tests in order to say, hey, the function is too slow, you need to optimize it. Okay, and I will show you once again JUnit 3 and JUnit 4. Okay, with this, and like I said, performance tests and test suites, collection of test cases, we cover everything that you can do with JUnit. Okay, like I said, the framework is very simple. It has very few syntax elements. You just need to know how to use them.